Welcome to myprojectbazaar.com. The project title is Space Codes for MIMO Optical Wireless Communications, Error Performance, Criterion and Code Construction. The project abstract is this specific design not only proves that a repetition code is the optimal linear FDSC optimizing both the diversity gains but also uncover a significant difference between MIMO radio frequency communications and MIMO OWC. That space dimension alone is sufficient for full large-scale diversity achievements. Computer simulation demonstrates the FDSC substantially outperforms encoded spatial multiplexing with the same total optical power and spectral efficiency, and the latter provides only the small-scale diversity gain. The project flow diagram is to measure the diversity gain for MIMO OWC. It means multiple input and multiple output for optical wireless communication. So initially we are creating on system model. So in the system model it is based on our MIMO related. It means a multiple input and multiple output system. So it is we are going to fix the number of transmission and reception. So next we have to apply the full diversity space code. So it is based on the diversity of our transmitter side. So next we have to apply the MIMO OWC. In that MIMO OWC, based on our process, it is depends upon the diversity gain governing the exponential decay of the error curve and small scale diversity gain and proceeding traditional power law decay. So it is only to based on our optical wireless communication in MIMO system. So next we have to logarithmic normal fading channel. So it going to get the fading channel of our logarithmic function. So next we have to detect the maximum likelihood detector. So it going to detect the power leakage of any reception side. So next we have to find the performance measure for corresponding the process. The project source code file was run from the command window. In current folder shows the main file.m. So it is our source code file. So we have to run that file. So the process will be going on. It is the each and every process to elapse time with seconds to will be shown. So the process was completed. So now we have to discuss each and every figure. In figure 1 shows the error performance of our SISO OWC. It means single input and single output for optical wireless communication. So it is the red color line shows the upper bound and black color line shows the simulation, and pink color line shows the lower bound, and blue color line shows that the benchmark. So our benchmark is related to our upper bound. The next label shows the ln square p and y label shows the average error rate. It is the value of to be shown in our process. So we have to discuss the value to u. So it is the simulation work. So next we have discussed the 2x2. It means a MIMO system for Bpsk system. So it is based on our ZF, means zero forcing and mean square error and maximum learn constraints. So we have to calculate the BER performance for EB by N0. So it is the curve. So our proposed system is upper bound. So it is the curve for our upper bound value. So it is based on ln square p and it is shown in the x label, and y label shows the logarithm of average error rate. It is the upper bound of our proposed work. When compared to existing, the proposed method is going to give the high performance. So next we have to discuss the BER. It means bit error rate for Bpsk modulation in antenna wavegain receive diversity. It is the various sigma value are shown in the figure. According to that figure, our proposed work is SISO sigma square is equal to 0.03. Our proposed work line will be shown on the blue color line. So next we have to discuss the measured and predicted page views, the weighted least square. So it is the sigma value to show the our performance. So it is the sigma square value equal to 0.01 is our maximum value of our process. In X label shows the page index and Y label shows the page view Y. The process demo was completed. Thanks for watching this video.